Which is more frightening, the thought that we are not alone in the universe, or the thought that we are? Pascal reflected on the vast indifference of the universe. He said, "The eternal silence of these infinite spaces terrifies me. I believe there will turn out to be a lot more to our universe than we currently imagine." Earlier this month, astronomers found a strange object moving quickly through our solar system. It is now called 3I Atlas. This is the third known interstellar visitor after Oumuamua in 2017 and Borisov in 2019. The discovery was made in July 2025 by the Asteroid Terrestrial Impact Last Alert System based in Hawaii. The name 3I Atlas follows the rules set by the International Astronomical Union. The first part, 31, marks it as the third interstellar object. The second part, Atlas, shows which program found it. Until very recently, we never even thought about interstellar objects entering our solar system. With technology advancing, we're seeing more and more objects. These objects are weird and strange. This one is about 12 miles long. That is around 20 kilometers. It is moving on a path that proves it came from outside our solar system. It is not pulled in by the sun's gravity. Its size is based on how bright it appears and how little light it reflects. Scientists believe objects like this are broken pieces from other solar systems. They may have been thrown out during the early stages of planet formation. This journey could have lasted hundreds of millions of years. It may even have taken billions of years. But if it went through a wormhole, it may just look like it's been traveling for billions of years. The object is now getting more attention because of a claim by Professor Avi Loeb. He teaches at Harvard University and studies space and physics. He also speaks often about the search for alien technology. Loeb says, 3I Atlas might not be natural. He thinks it could have been made by someone or something non-human. Loeb's ideas remain controversial, and many scientists do not agree with them. Still, he believes that strange paths and odd traits should be studied with care and an open mind. Professor Loeb says the large size of 3I Atlas may be too strange to explain with natural causes. He proposed it could be a spacecraft sent by an advanced civilization. He believes most interstellar objects should be small bits of ice or rock that got pushed out when planets formed. A body that is about 20 kilometers wide is extremely rare. It does not fit what we know about these kinds of objects. Loeb uses math models to back up this idea. These models show that large objects are far less common than small ones. If these models are correct, then something as big as Atlas should be millions of times rarer than Oumuamua. Right now, scientists are looking at two main ideas. One is that the object is a giant, solid piece of rock. It could be the core of a planetesimal that lost its outer layers. The other idea is that it might be a smaller icy object that looks bright because of a cloud of gas or dust. Its brightness helps scientists guess its size. A large dark object and a small bright one can shine in the same way. But no signs of gas release have been seen yet. Usually, we would expect a tail or glow if that were the case. Loeb doubts the natural explanation for two reasons. One is the size. The other is the path it follows. He points out that a large object moving toward the inner solar system at 60 kilometers per second is very hard to explain. Oumuamua moved at about 26 kilometers per second and Borisov at about 32. Loeb says no known natural process would send such a large object toward the sun at such high speed. He believes the fast motion and straight path suggest a kind of aim. That is not what we would expect from a random event in space. This leads to Loeb's bold idea. 3I Atlas could be a probe from another world. Its path might have been designed on purpose. Loeb continues to study how interstellar objects might move in ways that are not random. These ideas are part of the search for alien technology. This type of evidence does not depend on radio signals. It includes things like unusual paths or strange changes in speed. In this view, 3I Atlas could be like a light sail or a smart probe. It might even act like a self-replicating machine. Loeb's theory asks us to think about new kinds of alien signals. These would not come through radio waves. They might show up as odd paths or strange forces. The Galileo project supports this kind of thinking. It tries to find new ways to look for life beyond Earth. After studying its path, scientists confirmed that 3I Atlas came from beyond the solar system. Its long hyperbolic trajectory has an eccentricity greater than 1. This means it is not held by the Sun's gravity and will eventually leave the solar system and return to interstellar space. The same kind of orbit was seen in Oumuamua and Borisov. The speed of 3I Atlas, as it entered the solar system, was about 60 kilometers per second. That is around 135,000 miles per hour. This is much faster than the speed needed to escape the Sun's pull near Earth, which is about 42 kilometers per second. That supports the idea that it came from outside the solar system. What makes 3I Atlas different is the direction it came from. It appears to have entered from the area of the sky known as Sagittarius, which is close to the center of the Milky Way. This region has many stars, so it is a likely place for debris to be ejected. Many objects like this are thought to come from the local standard of rest. That is the average motion of stars near the Sun. Scientists track these paths using images taken before the object was officially discovered. These images can come from telescopes like Pan-STARRS, Subaru, or the Very Large Telescope. They also use orbit models made with data from NASA's JPL Horizon system. This modeling is often improved with star positions from the Gaia mission to guess where the object may have come from. NASA says that 3I Atlas will come closest to the Sun on October 30th, 2025. That point is called perihelion. At that time, it will be about 130 million miles from the Sun, which is about 210 million kilometers. That places it just inside the orbit of Mars. Mars usually stays around 1.5 astronomical units from the Sun. Atlas is expected to pass at about 1.4 units. This close distance might give scientists a chance to see more details. If the Sun's heat causes any gas or dust to come off the object, it could show signs of being a comet. Even though it is approaching the inner solar system, 3I Atlas poses no threat to Earth. At its closest, it will stay about 150 million miles away. That is around 240 million kilometers. This is about 1 astronomical unit, which is the same as Earth's average distance from the Sun. NASA's Center for Near-Earth Object Studies and the European Space Agency's NEO-Coordination Center have both ruled out any chance of impact. The object will pass well beyond even the orbit of Mars. Right now, 3I Atlas is about 300 million miles from Earth. That equals roughly 490 million kilometers, or about 3.3 astronomical units. This great distance makes it very hard to measure its size directly. Astronomers must rely on how bright the object appears and on assumptions about its surface reflectivity. This property is called albedo. If the object has a dark surface like that of an asteroid, it would need to be much larger to appear this bright. If it is more reflective, like a comet with an icy cloud, it could be smaller. But so far, no such cloud has been seen. Without direct images or radar data, its true size is still unknown. Current estimates depend on thermal models and standard ways to link brightness to size. These are the same methods used for distant objects in the outer solar system. More accurate tools, such as radar or stellar occultation, cannot be used yet because the object is too far away. Since 3I Atlas cannot be seen in detail, astronomers must estimate its size by measuring the light it reflects. This method compares the object's brightness to its reflectivity and overall light magnitude. From these values, scientists can use a formula to find the likely diameter. The main problem is that albedo can vary a lot. It depends on what the object is made of and how it is built. A dark, rocky asteroid may reflect only 4 to 6% of incoming light. That would give it an albedo around 0.05. A shiny comet with gas and dust could reflect much more. Its albedo might be as high as 0.5. Since no gas cloud has been seen around 3I Atlas, scientists must guess the albedo. This adds a large margin of error to the size estimate. If 3I Atlas is a solid dark object, then its brightness means it could be between 20 and 24 kilometers wide. That is an enormous size for any interstellar visitor. It would be far larger than Oumuamua. It would also be many times more massive. Mass increases with the cube of diameter. Oumuamua was about 100 meters long and shaped like a cigar. If 3I Atlas is solid, it could be 200 times longer and millions of times more massive. Professor Loeb points out that small objects outnumber large ones by a wide margin. Scientists use a power law to describe this. According to that rule, there should be millions of objects the size of Oumuamua, for each one the size of Atlas. Since Atlas is one of the first interstellar objects ever found, and also one of the largest, this raises major questions. This mismatch is part of why Loeb doubts a natural explanation. In an interview, he said that if Atlas really has a dark surface but still appears bright, then it may have been designed to stand out. It might even have been guided into the solar system on purpose. This idea fits with his view of technosignatures. These are signs of alien technology that do not depend on radio waves. They could include strange sizes, bright reflections, or unnatural flight paths. Loeb's idea is not based on size alone. He points to a mix of factors, including the speed, direction, and timing of the object's arrival. Together, these things do not match what we expect from random space debris. Professor Loeb asks a question. How many objects the size of Oumuamua exist for every object that is 24 kilometers wide? Based on what we know from planetary science, the answer is about 1 million. This comes from a rule called the power law, which explains how often we find different-sized space objects. The formula is n of d is proportional to d raised to the power of negative 3.5. That means as size goes up, the number of objects goes down very fast. If Oumuamua was about 100 meters long and 3I Atlas is 24,000 meters long, the math says there should be 1 million small ones for each large one, like Atlas. But Loeb points out something strange. We have not seen even close to that number of smaller interstellar objects. Before 3I Atlas, only 2 had been found. These were Oumuamua, which tumbled through space, and Borisov, which looked like a comet. Both were small, compared to Atlas. If our tools for finding these objects were truly complete, we should have seen many thousands or even millions of smaller ones already. But we have not. That is a problem. Finding something huge and rare before noticing the small common ones breaks what we expect from statistics. Yes, it is true that smaller objects are harder to find. They are dim, they move quickly, and they do not stay visible for long. Still, surveys like Pan-STARRS should have picked up more small ones by now. Some studies, like the one by Engelhardt and others in 2017, show there are limits to what we can detect. But even those limits do not fully explain this gap. This mismatch supports Loeb's belief that something is off. 3. Atlas does not just surprise us. It may completely change how we think about objects from other star systems. The mystery is not only about size. Loeb believes the real issue goes deeper. The fact that 3I Atlas exists at all raises new questions. These questions go beyond probability and into what is physically possible. If many objects this large existed throughout the galaxy, the total mass would be too great. It would break the limits set by current models. This extreme rarity might be a clue about how this object was formed. Loeb explores these ideas in a new paper that has been accepted for publication. It will appear in the research notes of the American Astronomical Society. This journal focuses on short scientific reports. In it, Loeb explains what it would take for something the size of 3I Atlas to reach our solar system. He wrote this paper with Amir Siraj, who often works with him. Together, they have studied how interstellar objects move and how often we should expect to see them. The paper looks at whether the arrival of such a massive object, measuring around 12 miles or 20 to 24 kilometers wide, can be explained by known natural processes or if it is statistically unlikely. The analysis builds on a method that Loeb and Siraj used before to estimate how many smaller interstellar objects, like Oumuamua, might exist in the galaxy. In that earlier study, they found that to detect even one object like Oumuamua, the Milky Way would need to hold about 10 to the 15th power of such objects. This assumes their paths are random and spread out evenly in space. When this same method is applied to 3I Atlas, the results are even more extreme. Seeing such a large object nearby suggests there may be other similar bodies in the solar neighborhood. If we apply this idea to the full volume of the Milky Way's disk, about 100,000 cubic parsecs, the number of such objects becomes incredibly large. The total mass needed for all of them goes far beyond what seems reasonable for debris that came from forming planetary systems. Simply put, the odds of something this large reaching Earth by chance are extremely low. That casts doubt on the idea that 3I Atlas is just part of a normal interstellar population. Loeb sees this rarity as a sign that we might be dealing with something out of the ordinary. This view becomes even stronger when 3I Atlas is compared to the two previous interstellar objects. Oumuamua was the first. It was long and narrow and probably made of metal. Its length was about 100 meters. Borisov came next. It looked more like a typical comet and had a core around 1 to 2 kilometers wide. By comparison, 3I Atlas is much larger. Its size is at least 10 times greater, and its mass could be thousands or even millions of times larger. That is because volume grows with the cube of size. This great size only adds to the puzzle. If it came here through natural means, we would have to believe that objects this large not only exist in deep space, but also find their way to our solar system. That idea does not fit well with current space models. For Loeb, the low chance of that happening supports the need to think about other possible explanations. Some of those could involve artificial origins. In his recent paper for research notes of the AAS, Loeb runs a basic calculation. He takes the local chance of seeing such an object and applies it to the whole galaxy. Then he multiplies by the mass of each one. The result, as he says, makes zero sense. In earlier work on Oumuamua, he showed that seeing just one such object already pushed the limits of what is possible in terms of total mass. In the case of 3I Atlas, the problem is even worse. The numbers are larger by many orders of magnitude. The path that 3I Atlas follows adds to the puzzle. Most interstellar objects arrive from random directions. Their paths are shaped by gravity and often change as they move. But 3I Atlas seems to be heading straight for the Sun. Its path is smooth and has little tilt. There is no sign of random turns or deflection. Loeb describes this motion as if the object had a target. That is hard to explain with natural forces. In the language of orbital science, random space debris should arrive from all directions. That is called an isotropic distribution. But a path like this one looks focused and precise. That makes it seem intentional. This brings Loeb to ask a key question. Why did the object come toward the inner solar system? If the path is too straight and the mass is too unlikely, then maybe the object's arrival was not random. Maybe it had a purpose. This kind of idea is not outside the boundaries of science. It grows from within those boundaries. Loeb connects his question to the growing field of techno-signatures. These are signs of intelligent life that do not rely on radio signals. A guided path that brings an object into the habitable zone of a star system might be one such sign. Other scientists have also looked at this idea. Some papers in SETI research have explored artificial probes, solar sails, and the idea of sending life across space. If we can see intent in motion, then 3I Atlas could be the strongest techno-signature we have ever seen. Professor Loeb is careful not to jump to conclusions. He continues to call for close scientific study of 3I Atlas. He does not claim the object is artificial. Instead, he presents it as a major anomaly in the data, one that should not be ignored. He says science should not dismiss the idea of an artificial origin too quickly. His method uses Bayesian reasoning and follows Karl Popper's idea that a good theory must be testable. To show how strange this case is, Loeb turns to Clarke's rendezvous with Rama. In the book, a huge cylinder enters the solar system. It turns out to be a spacecraft built by aliens. It never speaks or attacks. However, it clearly shows design and intent in both its shape and its path. The story asks what we would do if something like that came into our world. This question now feels close to real life, as scientists try to understand 3I Atlas. Loeb often uses science fiction to connect imagination with evidence. In his book Extraterrestrial, he writes about Clarke's work as well as stories like Contact and 2001: A Space Odyssey. He argues that fiction can guide scientific ideas. The link to Rama does not mean that Atlas is a spacecraft. It means that seeing something huge, fast, and silent come from outside the solar system is no longer just a story. It is something we have seen. Most objects from other stars arrive at odd angles. They are thrown out of their systems by chaotic forces. But Atlas is not like that. It is coming straight toward the sun. Its path has little tilt and shows no wild turns. That kind of motion fits more with a guided journey than with random debris. He asks the question that sits at the core of his idea. Why was it sent toward the inner solar system? This question is not just dramatic. It connects to SETI's lurker hypothesis. That is the idea that alien probes may already be watching us quietly. It also follows thoughts from researchers like Robert Freitas and Jason Wright. They suggest that long-lasting interstellar artifacts could make more sense than radio signals. A spacecraft does not need to send a message. Its arrival alone might be the message. For Loeb, this is a direct appeal to scientists. He warns them not to ignore something just because it seems unlikely. He urges the astronomy community to increase efforts to observe 3I Atlas. This is especially important as the object nears the Sun at the end of October. Key data could come from light curves, spectral readings, and signs of gas release, or the lack of it. These measurements will help reveal what the object really is. Loeb says, this is not a matter of belief. It is a matter of evidence. Science does not depend on belief. It is a process of learning from nature through proof. If the data keep pointing to something unexplained, then science must respond. It must ask bold questions. This should be done without bias. Loeb points to the coming Sun encounter. He says the good news is that the object will get close to the Sun and heat up. This will happen on October 30th when 3I Atlas reaches perihelion. This distance gives scientists a rare chance. The heat from the Sun might reveal the true nature of the object. If 3I Atlas has ice or gas inside, then sunlight should cause it to release those materials. This is called sublimation. It is how comets form tails and glowing clouds. As the surface heats up, gas and dust may escape. The rate of this process grows fast as the temperature rises. Loeb believes this will act like a natural test. The more the object heats up, the more mass it will lose if it is a comet. That will make it easier to figure out what we are looking at. The test is simple. If the object brightens, forms a tail, or shows signs of gas, then it matches what we expect from a comet. If nothing happens, and the object stays dark and solid, it is likely something else. It may be an asteroid, or it might be something more unusual. We have seen this kind of situation before. Comet Ison became very active near the Sun in 2013. It later broke apart because of extreme heat. On the other hand, Borisov, the second interstellar object, already showed a tail long before it came close to the Sun. That made its nature clear early on. Many scientists are preparing to watch 3I Atlas closely. Telescopes like the Very Large Telescope in Chile and the Subaru Telescope in Hawaii are expected to follow it during the closest pass. Space telescopes like the James Webb may also take part if time is approved. Skilled amateur astronomers are also being asked to join. Their home setups may help during this critical period. For Loeb and for others, this moment is not just a chance to observe. It is a moment of truth. If 3I Atlas starts to release gas, it supports the comet idea. If it does not, the case for other explanations becomes stronger. One way or another, the Sun will force the object to show what it really is.